Before we study algorithms in machine learning, we must clearly understand one fundamental concept, the dataset. The dataset. A dataset is the backbone of any machine learning algorithm, any machine learning system. Without data, there is no learning. In this lecture, we will study what a dataset is, its components, different types of datasets used in machine learning, how datasets are split, how preprocessing is performed, and what challenges we face while working with datasets. A dataset is a collection of data used to train and test machine learning models. This data can be present in different formats, such as tables, images, text documents, or time-based records. The structure of a dataset depends on the type of machine learning task we are solving. For example, customer data is usually tabular format. Images are stored as pixel matrices, and stock prices are stored as time series data. Datasets provide the foundation on which models learn patterns and relationships. If the dataset is poor in quality, incomplete, or biased, even the best algorithm will fail to give a good result. The next one is components of a dataset, features and labels. Every dataset mainly consists of features and labels. Features are the input variables or attributes that describe the data. In tabular datasets, features appear as columns such as age, income, gender, or location. Labels are the output variables that the model tries to predict. Labels are present only in supervised machine learning. For example, in a house price prediction problem, house price and locations are features and the price is the label. The relationship between features and labels is what the model learns during training. Components of a dataset, instances and data splits. An instance is a single data record in the dataset. Each instance contains a set of feature values and in supervised learning a corresponding label. To properly train and evaluate a model, datasets are divided into three main parts. So to properly train and evaluate a particular model, the datasets are majorly divided into three main parts: training dataset, validation dataset, testing dataset. The training dataset will be used to train a particular model or to develop a particular model. The validation dataset is used to validate the performance of a trained model, a model which has been developed with the help of a trained data. To validate the model, we will use validation dataset. To test set evaluates how well the model performs on unseen data. To test the model performance with new data or on unseen data, we will use test data. Properly splitting ensures that the model generalizes well and does not memorize the data. So memorization is completely different from learning. In fact, memorization, it belongs to the concept of rote learning, and learning aspect, it belongs to machine learning aspects, as it takes the data and try to perform the various aspects. And the next one is supervised learning datasets. Supervised learning datasets contains labeled data, meaning each input has a known output. The model learns by comparing its predictions with correct labels and adjusting itself accordingly. So it will try to adjust accordingly. There are two major types of will fall under classification datasets and regression datasets. Classification datasets where labels are in categorical format. Regression datasets where labels are on continuous values. Supervised datasets are commonly used because labeled data provide clear guidance during learning process. Next one is unsupervised machine learning datasets. Unsupervised machine learning datasets do not contain labels. Here the model tries to discover hidden patterns or structures within the data. Common tasks include clustering and dimensionality reduction. These datasets are useful when labeling data is difficult, costly, or impossible. For example, customer segmentation datasets often do not have predefined categories, and the model groups customers automatically. The next one is semi-supervised machine learning datasets. Semi-supervised learning datasets contain a small amount of labeled data and a large amount of unlabeled data. This approach is useful when labeling is expensive, but unlabeled data is abundant. The model learns from labeled data and improves its understanding using unlabeled data patterns also. This technique is widely used in image recognition, text classification, and web data analysis. Next one, reinforcement learning datasets. Reinforcement learning datasets are widely used to train an agent. They are generated dynamically through interactions between an agent and its environment. Each data record consists of state and action and reward. So in reinforcement learning data, we are having initial state and goal state like that. So an agent will start from initial state and his aim is to reach the goal state, and agent performance we are trying to monitor. The agent will try to learn the things on the basis of trial and error basis, guided by rewards and penalties. For every positive action, agent will get rewards, and for every negative action, agent will get penalties. Always an agent is trying to get the cumulative amount of reward points, not the penalties. The agent learns by trial and error, receiving feedback in the form of rewards or penalties. Such data sets are common in robotics, game playing, and autonomous driving systems. In all such situations, we'll use this reinforcement learning datasets. The next one is commonly used datasets classification. In machine learning, education and research, several standard datasets are commonly used for classification. Example like Irish datasets for flower classification, MNIST dataset for handwritten digit recognition, and CIFAR10 dataset for image classification, Titanic dataset for survival prediction. These are the various sets of data sets, and we call them as benchmarking data sets. We frequently use in machine learning algorithms for better understanding the behavior of the data. The next one, continuously. For regression problems, datasets like Boston housing and wine quality are widely used, and these datasets predict continuous values such as prices, or quality sources. They are used to compare different algorithms under standard conditions. Standard datasets help to ensure reproducibility and fair evaluation of machine learning models. So there are some commonly available datasets in machine learning databases, which facilitates us to understand the machine learning algorithms in a more effective manner and to understand the machine learning model assessment and the pattern identifications. The next one is dataset splitting is a crucial step in machine learning. Generally, 80% of the data it is used for training purpose, and in fact, it will vary from 60 to 80% of the data it is used for training purpose, and 20% of the data can be used for validation purpose. It varies. 10 to 20% of the data can be used for validation purpose, and 20 to 30% of the data for testing purpose. So, however, the data has to be split under 3 different segments, right? Training data set, validation data set, and testing data set. Special techniques like a stratified splitting are used for imbalanced data, and smart techniques also can be used, SMOTE. And time-based splitting is used for time series datasets. Proper splitting avoids data leakage and ensures unbiased evaluation. And the next one is data pre-processing, missing values, and scaling aspects. Real-world datasets are rarely clean. Almost the datasets are having some noise in the data. They often contain missing values and features with different scales. Missing values can be handled by removal or imputation. Scaling ensures all features contribute equally to learning. Techniques like standardization and normalization improves convergence and accuracy of models. The next one, data preprocessing, encoding and outlier removal. Machine learning algorithms require numerical inputs. So categorical data must be encoded using techniques like one-hot encoding or label encoding. Outliers are extreme values that can distort learning. Identifying and removing or treating outliers improves model robustness. The next one, challenges in working with dataset, imbalance and noise. Data imbalance occurs when one class or group has significantly more samples than others. Imbalanced datasets can lead to biased models favoring majority class over minority classes. This technique, techniques like resampling or class weights help addressing imbalance and improve the model fairness. Dataset imbalance occur when one class dominates the other class. This can cause biased models that ignore minority classes of the dataset or the model. Noisy data includes errors, missing values, or inconsistencies in the data. Handling imbalance and noise data is essential for fair and reliable predictions. And challenges in working with dataset, overfitting and privacy of the data. Overfitting, it is very clear that as the model perform well on trained data but poor on test data. Similarly, underfitting, it is also one of the problem as the model perform poor on both trained data and test data. So we are not expecting both overfitting and underfitting in the model development. Overfitting happens when a model learns training data too well, but it tries to fail on new data. Similarly, underfitting happens when the model is too simple and it will not work on both trained data and test data. Another major concern is data privacy, especially when working with sensitive information. So this is also one of the biggest problem. Techniques like regularization and differential privacy helps to address these challenges. And the next one, sources of data sets for machine learning. There are some major data set sources. UCI Machine Learning Repository provides popular data sets across many domains and problem types. Kaggle platform hosts datasets and machine learning competitions with a diverse data collection. Google Dataset search enables discovery of datasets across various domains and the research areas. OpenML platform facilitates sharing datasets and machine learning experiments for reproducibility. These are the various sources of datasets for training, testing, and benchmarking model. And in fact, we can able to download many data sources. We can able to download many datasets from various sources from UCI, and majorly I use Kaggle and UCI data sources to download the required data set.